My name is Mariam Mehran, CEO and co-founder of MAA'VA. In Persian, MAA'VA translates to a safe place to thrive. I try to embody this notion as an architect designing sustainable luxury homes. But I would ask myself how to make our planet a safe place to thrive, not just for a select few, but for everyone.
As our population continues to grow and as our buildings age, we will quadruple our demand for precast concrete by 2050. Concrete is in the foundation of your home, the bridges that connect us, the aqueducts that carry water and hydrate our communities. This humble mixture of water, cement, aggregate, and river sand keeps our rapidly growing cities upright. As the world realizes cement's huge carbon footprint, there has been a wave of innovations across the supply chain. But one critical aspect has been overlooked: sand. Up to 50 billion tons of river sand is dredged every year just to be used in concrete. There is even a black market for it. At MAA'VA, we are building on years of research aspiring to make concrete by replacing river sand with waste plastic, reducing water use, and curing with captured CO2. For 40 years, scientists have tried to incorporate plastic into concrete, but the challenge is maintaining compressive strengths. Recently, scientists at MIT stably replaced 2% of river sand, but in the last 2 years, our team broke the record at 40%.
I'm Dr. Monica Blazinski, CSO and co-founder of MAA'VA. At MAA'VA, we designed a new chemistry that can do with cement and plastic what others cannot. Multiply the number of binding sites so that our concrete can still meet the ASTM standards, all while still being lighter and more sustainable. This means building with lower rated structural elements. And rather than taking the typical 1 month to cure, our precast concrete takes just 1 day. The impact? Lower labor costs, which can be up to 40% of the cost of construction. Our proof of concept shows that recycled plastic can be used in meaningful amounts. Now, we're working to design a manufacturing process that can be scaled and cost competitive with structural concrete without compromising performance.
Next, we'll be designing this process to scale at economics that competes with raw concrete, so that we can service our multiple LOIs with sustainable housing development, multinational furniture companies, and beyond.
Join us as we create the next generation of green building material.